All right, so welcome back. We are doing lesson 7.2 um, for integrated three. Excuse me. And so I don't know what happened to my PDF, but for some reason this is supposed to say jumpstart. So we're going to do the jumpstart problem, and we're actually going to do it together. Sometimes I have you guys do them in your groups, but today we're going to make sure that everybody understands how to do this. So it says find the measure of angle Q in the following diagram, and then represent your solution process. Okay, so what they're asking you to do here is what is theta? Okay, and so if you remember, whenever we have right triangles, we're always excited because there's two tools that we basically use. Hopefully you remember those two tools. What are the two tools? Number one, Pythagorean theorem, or number two, SOHCAHTOA, sine, cosine, tangent, basically trig. So for this particular one, we're not going to be using Pythagorean theorem, because they're asking us to find theta. So which trig function, sine, cosine, or tangent, relates this side and this side? And hopefully you said sine, because then you'd be right. So then we go sine of theta equals to 3/4. And then you're like, theta's stuck in sine. So then I ask you, okay, well, how do we get theta out of sine? How do we undo that? So then hopefully you remember, we just sine inverse both sides. So I'm going to copy this so I get sine theta equals to 3/4, except for I'm going to leave a little space so I can sine inverse both sides. Sine inverse. And so the sine inverse, okay. Sine inverse cancels, right? They undo each other. I'm left with theta equals to sine inverse of 3/4. And you're like, okay, Ms. Johnson, but I don't know what that is. Yeah, neither do I. So what we do is we bring in our handy dandy calculator and we start typing in sine inverse. So in case you don't know, let me turn this off. In case you don't know where sine inverse is under functions. And there it is right there. Do you see sine inverse right here? Okay, so that's what sine inverse looks like. You can also type it in, sine, and then shift 6 makes it go superscript. And then I'm just going to type 3 divided by 4. Now, this answer is in radians. How do you know that? Because I didn't change it. So it's just going to be in radians. Now, if you want it in degrees, then you'd hit the degree button. So because I have this right there, I'm going to write that down so I don't lose this. So theta is about 0.848 radians. And then now I'm going to push the degree button, and it says 48.59 degrees. So I know some of you are like, I don't like using decimals, so then you'll probably go back to degrees for this. That's fine. So there you go. And that is our answer. So things that you should remind yourself is whenever you have a right triangle, you have two tools basically at your fingertips. It's Pythagorean theorem or the trig. And then so that's what you're supposed to use. And then so for number 2, we're going to do similar. It says find the measure of angle theta if in the given diagram. Represent your solution process using equations. So same thing goes here. What you're going to be doing is you're going to do the same thing that Ms. Johnson loves doing. She draws the right triangle to your hypotenuse. And that wasn't very straight, but that's okay. We're not going to worry about that. And we're going to use our reference angle, and I'll call our reference angle, I'll do alpha this time. So I'm going to use my alpha angle just to figure that out. And now we already figured the angle out, the reference angle, because look, it's this is -3 and this is -4, right? So it's that same triangle that we just used, except for it's, let's see, what is it? Oh, it's not the same triangle. Johnson is wrong. It's not the same triangle because I don't know if you guys saw this. Miss Johnson was mistaken. She saw the 3. She saw the 4. She's like, yes, that's what it is. It's not. So hopefully you saw that this time the 4 is the y, like the y distance instead of the hypotenuse. So now I'm not going to be using that. So what equation can I now write using that to figure out alpha? and it says that your radius is 5, right? So you could either use sine, cosine, tangent. It really doesn't matter. I don't know why, but I've told you guys this before. Sine is my favorite, so I'm going to use sine. So I'm going to go sine of alpha equals to -4/5. And if you get negative, just know I'll explain what it'll show you on the calculator, just so that you're comfortable with it. And then you're like, alpha is stuck in my sine. How do you get them out? And you're like, oh, no problem. It's the inverse. So we're gonna do that again. So we're gonna sine inverse both sides again. And then this will cancel. So I get alpha equals to sine inverse of 4/5. Oops, negative. Let's put that negative in there. And then we're going to type this in. I'm going to show you what your calculator is telling you to do. So -4/5. Okay, so your answer, right now it's in degrees because that's what we have it in. Okay, that's what we have it in. So it says -53 degrees. -53 degrees. So Ms. Johnson, what does -53 degrees mean? So if you remember before, we learned that when you start at 0, this is starting at 0, and you go this way, this is positive. So that implies if I go the other direction, if I go this direction, this is negative. So when it's saying -53 degrees, it's actually finding this as -53 degrees. Does that make sense? So it's almost like a reflection of that triangle that we just drew. Does everybody see my reflection? I cannot draw straight lines today at all, so you're just going to have to bear with me. Thank you. And so this is that negative. Excuse me. Yep, we're still getting over the cold. So that's -53 degrees. Okay. If I take that negative out of there, it's just 53 degrees. So if you think about like when I'm graphing on a number line and I say this is 0 and I say this is -5, it's really 5 units away from 0, just in the left direction, right? So if I take out that negative from my 53.13 degrees, it's just saying that's the angle opening of that angle right there. So are you saying, Ms. Johnson, that alpha is 53.13 degrees? Yeah. So this angle here is 53.13 degrees. If you want to switch that over to radians, that's fine. But right now I'm just going to leave it in degrees. So then the question still is, Ms. Johnson, hey, they asked us for theta. Theta is that whole green angle. How would I find that? So you tell me, how would I use 53.13 to find that? Very good. So you would just basically add 180 to 53.13. So I'm going to do that. I'm going to add 180 to that. So then I get 233.13 degrees. So remember that the 180 is this part and goes across, and that 53 is that extra little angle there that you're adding to it. So my theta is approximately, it's not equal to 233.13 degrees. Okay, so there's your jump start. If you wanted to remember, this is just a little bit of a reminder how you use sine inverse. Okay, and then watch video 2 for the rest of this lesson. Thanks for listening.